Hello, my name is Yud Joshi and I'm currently studying at Marwad University pursuing my BTech degree in ICT, Information Communication Technology. Today I am going to talk about satellite orbits, a topic of my conceptualization topic given and guided by our professor Chandra Singh Parmar for the subject ICE, Introduction to Communication Engineering. So let's start. So first, the introduction of orbits. Usually, an artificial satellite needs to have an orbit, the path in which it travels around the Earth. The orbit can be equatorial, inclined, or polar. The period of satellites, the time required for a satellite to make a complete trip around the Earth, is determined by Kepler's law, which defines the period as a function of the distance of the satellites from the center of the Earth. Now, there are three types of satellites orbits, namely GEO, which is geostationary orbit, second MEO, which is medium Earth orbit, and third LEO, low Earth orbit. So here is the first one. Here is the first one, GEO. To an observer on Earth, a satellite in a geostationary orbit appears motionless in a fixed position in the sky. This is because it revolves around the Earth at Earth's own angular velocity. A geostationary orbit is useful for communications because ground antennas can be aimed at the satellite without their having to track the satellite's motion. This is relatively inexpensive. In applications that require many ground antennas, such as direct TV distribution, the savings in ground equipment can more than outweigh the cost and complexity of placing a satellite into orbit. Advantage of GEO is the advantage is that ground antennas do not have to track the satellite across the sky. They can be fixed to point at the location in the sky the satellite appears. Here are some examples of GEO. The first geostationary satellite was Syncom 3, launched on 19th August 1964 and used for communication across the Pacific starting with the television coverage of the 1964 Summer Olympics. Shortly after Syncom 3, Intelsat 1 aka Early Bird was launched on 6th April 1965 and placed in orbit at 28° west longitude. It was the first geostationary satellite for telecommunications over the Atlantic Ocean. Second, on 9th November 1972, Canada's first geostationary satellite serving the continent, ENIC A1, was launched by Telesat Canada, with the United States following the suit with the launch of WestStar 1 by Western Union on 13th April 1974. The third one, on 30th May 1974, the first geostationary communications satellite in the world to be three-axis stabilized was launched, the experimental satellite ATS-6 built for NASA. This was for GEO. Now we come to another type of orbit satellite, which is MEO, medium Earth orbit. A medium Earth orbit is a satellite in orbit somewhere between 2000 and 35,786 kilometers above the Earth's surface. MEO satellites are similar to LEO satellites in functionality. MEO satellites are visible for much longer periods of time than LEO satellites, usually between 2 and 8 hours. MEO satellites have a larger coverage area than LEO satellites. MEO satellites' longer duration of visibility and wider footprint means fewer satellites are needed in a MEO network. One disadvantage is that a MEO satellite's distance gives it a longer time delay and weaker signal than an LEO satellite, although these limitations are not as severe as those of GEO satellites. Typically, the orbit of a medium Earth orbit satellite is about 16,000 kilometers above the Earth. In various patterns, these satellites make the trip around Earth in anywhere from 2 to 8 hours. Here are some examples of MEO. In 1962, the communication satellite Telstar was launched. It was a medium Earth orbit satellite designed to help facilitate high-speed telephone signals, although it was the first practical way to transmit signal over the horizon. Its major drawback was soon realized because its orbital period of about 2.5 hours did not match the Earth's rotational period of 24 hours. Continuous coverage was impossible. It was apparent that multiple MEOs needed to be used in order to provide continuous coverage. In 2013, the first four constellation of 20 MEO satellites was launched. The O3B satellites provide broadband internet services, in particular remote locations and maritime and in-flight use, and orbit at an altitude of 8063 kilometers. This was for MEO. Now we're going to talk about LEO. LEO stands for Lower Earth Orbit. So what basically low Earth orbit means? It is typically a circular orbit about 160 to 2000 kilometers above Earth's surface and correspondingly a period of about 90 minutes. Because of their low altitude, these satellites are only visible from within a radius of roughly 1000 kilometers from the sub-satellite point. In addition, satellites in low Earth orbit change their position relatively to the ground position quickly. So, even for local applications, many satellites are needed if the mission requires uninterrupted connectivity. Low Earth orbiting satellites are less expensive to launch into orbit than geostationary satellites, and due to proximity to the ground, do not require as high signal strength. Thus, there is a trade-off between the number of satellites and their cost. In addition, there are important differences in onboard and ground equipment needed to support the two types of mission. Here are some examples of LEO. The International Space Station is in a LEO about 400 km to 420 km above Earth's surface and needs reboosting a few times a year due to orbital decay. The Iridium Telecom satellites orbit at about 780 km. Earth observation satellites, also known as remote sensing satellites, including spy satellites and other Earth imaging satellites, use LEO as they are able to see the surface of the Earth more clearly by being closer to it. A majority of artificial satellites are placed in LEO. Satellites can also take advantage of consistent lighting of the surface below via sun-synchronous LEO orbits at an altitude of about 800 km and near polar inclination. NVSat is one example. The Hubble Space Telescope, famous one, orbits at about 540 km above Earth. The Chinese Tiangong space station was launched in April of 2021 and currently orbits between about 340 kilometers and 450 kilometers. This was about the LEO. Now here is the conclusion of this topic. As satellites in MEO and LEO orbit the Earth faster, they do not remain visible in the sky to a fixed point on Earth continually like geostationary satellite, but appear to a ground observer to cross the sky and set when they go behind the Earth beyond the visible horizon. Therefore, to provide continuous communications capability with these lower orbits requires a larger number of satellites, so that one of these satellites will always be visible in the sky for transmission of communication signals. However, due to their closer distance to the Earth, LEO or MEO satellites can communicate to ground with a reduced latency and at lower power than would be required from a geosynchronous orbit. So here we conclude that LEO and MEO satellites can communicate with the reduced latency because of its distance from the ground in comparison with geosynchronous orbits. Thank you. If you have doubt or anything, you can share me in the comment section below. Thank you so much for watching.